And this frame is square, it is. And in fact, being an inch and a half on each side, the frame is bigger. This is interesting. If you would add up the area of the frame would be 81 square inches. The area of the frame is 81 square inches. Well, guess what? I don't know the length of this square frame. Since I don't know this is algebra, I'm going to say it's x. And since it's square, they're both x. And because this is an inch and a half on each part of the frame, the whole length would be how much less? Since each part of it's an inch and a half, the whole thing would be, how about somebody say 3? An inch and a half here, an inch and a half here. Would it be 3 less? Those who haven't noticed, the lesson has started. Okay. It would be 3 less. So in fact, this would be x minus 3. And because it's squared, this would be x minus 3. And so it says the area of the frame, just the frame, so example, the frame here, that is me and Amber, some survivor. The area of the frame would be this. It would be the area of the big part, like the whole thing, take away the area of the picture. The area of the big thing, take away the area of the picture, and we're told that that is 81 square inches. Well, probably the easiest formula you did in geometry was the area of a square, which is simply side times side. I don't know if I was listening to me. The area of the big thing would be x squared, x times x. If we take away the area of the picture, we're going to get the 81. So it is x minus 3 squared. Now, although this is a word problem, allow me to remind you that x minus 3 squared must, not optional, must be gone x minus 3 times x minus 3. In fact, that will come up in some of your factoring review, and that will come up on your factoring test. X minus 3, you have to go first, outside, inside, last, and that's going to become a 6x. So I've got x squared minus x squared. 3x and 3x is minus 6x plus 9. We've taken the area of the big minus the area of the picture, becomes 81. I'll write this a little higher up now. We do distributive property. The negative comes through here and you get minus x squared. Comes through here, you get plus 6x. Comes through here, you get minus 9 equals 81. All of a sudden, this problem about a picture from Amber Survivor and me has come down to an algebra problem. The x squared subtract away, and you get 6x minus 9 is 81, and there's not a one of you here who is stressed out to see this. Divide by 6, I believe it is 15. The answer is the frame is 15 by 15 inches. So we had something like this. It was in a square. The frame was bigger than the picture. We knew the area of the frame, and we could calculate the size of the square. I'll wait 14 more seconds as I see some people are writing it down. If you were in Mrs. Furchow's class, she would talk about gravity. And gravity, there are so many people who don't like gravity. I watch the Olympics. There are people that try to jump and defy gravity and they always fall. There are people that have large poles and they try to defy gravity and they fall. There are snowboarders that try to defy gravity and they come back. Gravity seems to always work. And Mrs. Fairchild would say this. She would say that the height above the ground equals negative 16 t squared. T would be the time in seconds. The negative 16 is the fact that gravity is always pulling down to the ground. Have any of you read The Hitchhiker's Guide to the Galaxy? Oh, that must be now getting to be an old book. They tell you how to fly. It's extremely easy how to fly. Throw yourself at the ground and miss. That's how to fly. I'm going to write this. I'm going to write plus 32t. This would be the upward velocity. This would be 32 feet in 1 second. So our building is maybe 32 feet high. So think of having a ball and throwing it, and 1 second later it's high as the building. So that'd be a pretty fast throw. Not impossible. Not impossible to, in 1 second, have it there. Think of a baseball bat or a softball or a lacrosse player who forgets to let go of it and it goes straight up. Okay, that's possible. Or let's go with too soon. And I'm going to put a plus 128. That's how high you are above the ground. So in fact, we're standing on top of a pretty tall building. Pretty tall building. The cliff that I'm hanging off back there in Telluride is 300 feet off the ground. I was scared. When something hits the ground, it's how high off the ground? It's 0 off the ground. And the question I'm going to ask is, when would this hit the ground? So gravity is pulling it. You're throwing it up in the air. You're standing on something pretty tall to start. It's going to hit the ground in 0. I'm all of a sudden going to be able to throw a little bit of review into what we're doing. We're going to be factoring that. We're going to be factoring that. And to factor that, we always try to use the distributive property. See if there's something that goes into everything. And we try to get the biggest thing we can. Well, it's possible at 16. Get your calculators out. All right. I don't think you need your calculator to see, does negative 16 go into 32? I'm pretty sure you've got that one in your head. You might need to use your calculator to know if negative 16 goes into 128. I don't know if it does or not. Of course I do. I did the problem first hour, but I'm just like pretending. Does it? How many times? Calculator says 8 times. So here we go. This is reviewing. We're putting a little review in there. Negative 16 goes into all of them, leaves a t squared. 32 divided by negative 16 is negative 2. Some of you have just told me that 128 divides, or 16 into 128. How many times your calculator says? 8. Cool. You must bring the negative 16 along. All right, this would be an easier factor now. I want this to multiply to be negative 8. 1 times negative 8. And I look in the middle. I want to add to be negative 2. And that's not too difficult. Those numbers would be, I believe, negative 4 and 2. Let me double check. Does that multiply to be negative 8? Say yep. Yep. And it adds to negative 2. Yep. When the leading coefficient, when the number out in front is 1, you just go straight to the answer. T minus 4, T plus 2. Your teacher now would say the zero product property, we call it the big T. And in fact, it's a really big T. And we write down negative 16 equals 0. We write T minus 4 equals 0. And we write T plus 2 equals 0. So we're throwing a little review into all of this. Well, here I'm going to add 4 to both sides. And I'm going to take away 2 from both sides. Now, Some of the teachers at Eastridge would look at this and go, negative 16 equals 0. They go, wow, we didn't know that. Pretty interesting. I didn't know that. Must be a fact. No, it's not a fact. If the variables are gone, Eastridge teachers, if the variables are gone and it doesn't make sense, it's an answer that algebraically worked, does not work in our problem. T equals 4, hits the ground in 4 seconds. That works. Yesterday we used the word, or 2 days ago we used the word extraneous, an extra answer. This says it would hit the ground 2 seconds before you throw it. Okay? Extraneous. It would hit the ground in 4 seconds. This is not going to be on the test. What I just did is not going to be on the test. Somebody in first hour told a few of you because you weren't paying attention. Most of you that hadn't heard, I didn't tell you at the beginning because I wanted to pay attention. If I were here on Monday, I would go over 2 or 3 more examples of this and we would get it. I'm not going to be here on Monday. I don't want us to get any further behind. You're not behind. We're just 1 day slower than we should be because of my absence, and that's nothing for you to worry about. But I don't want to get 2 days slower. So those story problems are not on the test. All right, but maybe you learned a little something. All right, real quick, check your phones for just a